Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and in this video we are going to implement some state machines for animations for the entities in our game. So we are going to start by adding only one additional animation to our monster apart from the idle frame. That is also going to be a single frame animation, but this is going to give us an overview of how animations are going to work, and we are going to integrate it so that we can specify animations by name as well, just like we are specifying the sprites by names, which will make our jobs a lot easier. So first of all, I am going to open up the resources.h here. In here I've got a utility function here, just an int called getSprite, which takes a name and it returns an int which is the index of the sprite texture. And if I open up resources.cpp, you can see this basically just finds that name in the sprite names, and if it is not equal to n, it returns the second value, else it returns -1, which indicates an incorrect sprite, incorrect texture actually. The same thing basically. So yeah, this is going to be a utility function which is going to be very useful. So let's open up thing.h and take a look at how this works. So in here we have basically got one more thing here inside of our thing, which is that we have got a unique pointer to an animator of int here. As you know, our animator is a templated class that can be of many different types. This is an animator of integers, which means the texture indices, the sprite indices, and we have got a unique pointer because each thing will have a separate animator. And of course this may be null if the thing does not have an animator, if the thing is not animated. So yeah, this is going to be present in our thing as a public variable, public member variable. And if I go to the thing definition here, you can see that in here we have got a vector of vectors of pairs of floats of strings. What does that mean? That means that this basically is a vector of animations, where each animation is basically a vector of floats and strings. So the float represents the time step while the string represents the name. The reason we don't use animation here directly is because our animations are actually going to be animations of integers, not of names. So we actually store just a vector of pairs, so that it is easier to specify these and then convert these to that format. So in thing.cpp currently we have got only animations for monster, because well, that's the only thing that needs animations. And in here we have got only one animation, which is the monster pain state. I've just used again the original Doom files here, which had a single pain state which lasts for like a split second. The time is 0.1 here, and we only specify monster pain 0 here. And if I actually get a listing of the sprites directory, you can see we've got pain 0 through pain 7, but it only specifies pain 0 here. And of course the additional values are added automatically based on whether the monster is directional or not. The monster is directional, so it gets the direction and it handles that correctly. So this is our thing here, and yeah, this is going to be pretty much all for the actual thing definition. Now let's go to game.h, actually not game.h, game.cpp. And in here you can see that what we do is, when we are initializing our things and creating everything, we use this resources getSprite to get our texture here. And if our animations are not empty for the current thing definition, then that means that we are going to create a vector of animations of ints, which is what the thing is actually using. And for each animation in the def.animations, which is this animation again is just a vector of pairs, we create a vector of keyframes for this integer animations, and then we loop over each of the actual frame of pair of time and the name of the texture in our anim. And when we are looping over that, then we just push that back onto our keyframes vector. In the end, we push the back onto our animations vector, and we create an animation with the keyframes. And in the end, we use make unique to get a new animator here, and we pass it our texture and our animations. And as you can see, this is going to pretty much just convert the names data to indices, and then have that be present here as animations. And another thing is that when we are updating our game, if our thing has a thinker, we update the thinker, and if it has an animator, we update the animator as well. Now inside of render.cpp there is just a minor change. When we are looping over our things, we actually create a separate integer called thing texture, which we use instead of this. And for this we just check if our thing texture, if our thing animator is valid. If it is, then we use the animator here to get the texture. And by the way, we have to actually dereference this first. That's because unique pointer also has a member function named get, and our animator also has that. So to prevent a conflict, we need to do it like this. And then if it is if the animator is not present, then we just use the thing's default texture. And the rest of the code pretty much is the same, except that we use thing texture here instead of the other ones. So if I go ahead and run make, what you should be able to see is that I can go ahead and I can shoot the monster, and it displays its frame. So as you can see, this works, and this is going to be pretty much it for this video. I'll see you in the next one, in which we are going to add some more features to this, because we can extend this to a better state machine system, adding running and pathfinding for the monsters. So that's going to be pretty awesome. So stay tuned for that. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one, and bye.